everybody. My name's Sheila. I work for the Royal Astronomical Society. I'm a planetary scientist, and I'm going to take you on a journey through the solar system today, which should be quite exciting, seeing as we are all confined to our houses and our local areas at the moment. Now, the interesting thing about these kinds of situations, this sort of lockdown situation, it's like it's very similar to being an astronaut on your way to somewhere like Mars and being in a spacecraft for 2 years with 6 other people in a confined space. So if you start to feel a little bit bored during this situation where you can't go to school and you can't see your friends, just pretend to be an astronaut, because it's just like being an astronaut in space and not being able to go outside and not being able to mix with other people. So what we're going to do is I'm going to talk to you about the solar system and astronauts today. So I will put some slides on here. And if you do have questions during the talk, do type them into the chat box. I will try and keep an eye on them, but of course I will be also talking. So if I don't manage to see your question during the talk, then I can definitely answer questions at the end. And I'm seeing some very cool Lego models of the solar system and some very, very cool spacey backgrounds at the moment. Okay, so like I said, my name's Sheila. I work for the Royal Astronomical Society and I'm a planetary scientist, which means I've studied space since I was I've been interested in space since I was about 13, and my job has taken me all over the country, all over the world. I've been to America, I've been to Russia, I've been to Australia. I do cool experiments, I meet really, really interesting people. And my favourite planet is the planet Saturn, and that's because I studied the planet Saturn when I was doing my PhD. Now, a PhD is something you do after university, and you study a particular thing and you study it so much that you end up writing a book about it, and then some people test you on that book, and if you pass your test, then you get to call yourself a doctor. So I am Dr. Sheila Kanani, but I'm not a medical doctor. I'm a doctor about space, and particularly about the planet Saturn. Now, I work for a place called the Royal Astronomical Society, which is what we call a learned society. It's a membership organisation for people who work in the space industry or the field of space. So people that do astronomy, space science, some astronauts and teachers, some geophysicists who look at volcanoes and earthquakes. And the building is in central London, although I don't live in London. And when the building is open, it's quite impressive. There's a nice library, and in the library there are books by Newton and Galileo, some of the astronomers that you might have heard of. And it's a very, very cool place to visit. So if you do ever pop down to London once all this is over, do let me know, and I will try and let you inside the building to have a visit. And what we do at the Royal Astronomical Society is we represent astronomers and geophysicists all over the world, and we support them in lots of different ways. And we have a team of people doing that. So we have a council and we have a president. So on the bottom left of this picture, you can see a black and white picture of a man, and that man is William Herschel. He was alive in the 1700s, so a long, long time ago. The Royal Astronomical Society is 200 years old this year, and William Herschel was the first president. William Herschel was also the astronomer that discovered the planet Uranus. So he was really special in his time for the studies that he was doing. And he had a very famous sister called Caroline Herschel. Next to that black and white picture is a colour picture of a man. He is called Professor John Zarnecki, and he has been a president of our organisation as well. And I like to show these two pictures because you can see that the two men look really similar, even though those pictures are 200 years apart and they are not the same person at all. And that is because I think people imagine astronomers to look a particular way. And hopefully you will see that astronomers can be anything, any type of person can be interested in space and in the space industry. And if you are interested in working, when you're older, working in the space industry, there are lots of jobs out there for you. If you like space, there is obviously the job of astronaut. And in the middle of this picture, we have astronaut Tim Peake, who was the first British paid astronaut and went up into space a few years ago. But it's not just about being an astronaut. You could be an engineer, you could be a research scientist, you could be an astrobiologist and look for aliens. You could be a planetary scientist like me, or you could work in the Antarctic, or you could build things that look at the bottom of the ocean. There's lots of cool jobs in the space industry. And there are some more unusual jobs in the space industry too. So if you like drawing, you could be a space artist. If you like law, you could be a space lawyer. If you like cooking, you could be a space chef. And recently, NASA, the space agency in America, put an advert in the papers saying, we need a vet, we need a space vet, because they're taking more animals into space now and they need someone to look after them. So if you like space and if you like doing other things, then you could work in the space industry. You could work in the field of space because there is a job out there for you. So onwards to planets. Now, I love talking about the solar system and I love talking about planets because we have managed to send satellites to and spacecraft to lots of different planets in our solar system. But sometimes, and maybe at school or when you're learning about space, you might come across pictures like this. And what we're looking at is the sun, or a little bit of the sun in the bottom left-hand corner. And then we have Mercury, Venus, Earth, and the Moon, Mars, Jupiter, Saturn, Uranus, and Neptune. But there are lots and lots of things that are wrong with this picture. If you want to, you can type to me or type to everyone what you think is wrong with this picture, or you can just discuss it with the people that you're with. So what is wrong, or what do you think is wrong with this picture? Have a little think. Okay, so people are saying the wrong scales and distances. The Earth is too big. They're all different sizes. All the planets except for the Earth are the same size. The distances are not right. The Moon's too small. Jupiter should be bigger. Earth shouldn't be the biggest. They shouldn't be in a straight line or in a row. Yeah, see, there's lots and lots and lots of stuff that is wrong with this picture. But luckily, we have some avid astronomers out there, and you are guessing absolutely correctly that the sizes are wrong and the distances are wrong and the planets should not be in a straight line. You're absolutely right. This picture is much more realistic. So here you've still got all the planets in a straight line. So that's wrong, and the distances between them are also wrong. But what you can see now is the sizes of the planets and the sun. These are all real pictures taken by spacecraft. But what we've done is got the pictures and chopped them up and put them all together to give you a view of the solar system. So now, again, we have the sun on the left-hand side. And remember, the sun is a star. It's not a planet. It's a big ball of burning gas. And all the things in the solar system, all the planets and everything else in the solar system go around the sun. They go around our nearest star, the sun. Then we have tiny little Mercury, Venus and Earth and the Moon, then Mars, and then the asteroid belt. Then we have Jupiter, Saturn, Uranus, Neptune, and Neptune. And if you've got really good eyesight, the little white blob on the right hand side is Pluto. Now Pluto is now classed as a dwarf planet. So there are 8 main planets in our solar system. And there are other dwarf planets in the solar system as well. And there's a bunch of other things like asteroids, meteoroids, space junk, all kinds of stuff in the solar system. And we're going to first have a look at the sizes of the planets. So here's another cartoon. This is to scale. The big orange circle at the back is the sun. And then you can see Jupiter, Saturn, the Earth, and the Moon to scale if the Sun was that big. And you can see the Earth is tiny and the Moon would only be like a dot or a full stop in terms of size in relation to the Sun if the Sun was that big. So I've got another little quiz for you. What we're going to do now is I'm going to give you, or virtually give you, 8 different objects, and you have to put them in, you have to work out which objects represent which planets in the solar system. So we are talking about Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I don't want to know about the Sun or the Moon or Pluto, so just the 8 planets. And the objects are a watermelon, they are a grapefruit, an apple, an orange, a cherry tomato, in fact 2 cherry tomatoes, because 2 planets would be the size of cherry tomatoes, 1 blueberry, and 1 peppercorn. So have a think with the people next to you. Again, you can type into the group chat if you want to. And there's a few questions coming up about telescopes. So who has the most powerful telescope? Oh, good question. I think it's probably the telescope in Chile, but I'm not 100% sure. And then there are obviously telescopes in space as well, which are also very, very powerful. So have a think about those 8 objects representing the 8 different planets if we scaled our solar system down into the size of a fruit solar system. And if you don't want to give away the answers to everyone, you can private message me, or you don't have to type in the chat at all. But we are seeing some answers here. So Jupiter's a watermelon, Mercury's a peppercorn. Okay, have another think, and then we will we'll go through the answers. Okay, blueberry, Mars, apple and orange, Neptune and Uranus. You guys are pretty much on the ball today. So the watermelon is the largest object in our fruit solar system. Therefore, the watermelon has to be Jupiter. So well done to those of you that said Jupiter was the watermelon. Excuse me. The next largest object in our solar system is Saturn. So the grapefruit is Saturn. Then we had Uranus and Neptune are the next 2 biggest objects in the solar system. So we have Uranus there is the apple and Neptune is the orange. Then we have 2 planets that are very similar in size, and some people are guessing correctly. The cherry tomato is one of those planets is Earth, and actually the other one is Venus, because Venus and Earth are very similar in size. So they would both be the sort of size of a cherry tomato. Then we have Mars is the blueberry, and the tiniest planet in our solar system is the peppercorn or Mercury. So just have a think about that for a moment. If we scaled the planets down into the size of these objects, Jupiter would be the size of a watermelon, a pretty big, hefty planet, and Mercury would be just the size of 1 peppercorn, absolutely tiny. And even the Earth is not that much bigger, the size of a cherry tomato in relation to massive Jupiter. So it really is quite impressive how big our solar system is and how small the Earth is. But of course, the Earth is important because it's, as far as we know, the only place with life on it. And this is a real picture of the sun taken by a solar satellite. And the sun is really, really active. It's a big ball of burning gas, and it's also giving off energetic particles. So there's stuff spewing out of the sun all the time. and this energy and this radiation does actually reach the Earth, and it spreads out all the way to the edge of the solar system. But what the Earth has is a magnetic field. So the Earth is protected by a force of magnetism, and that is really good. That's really lucky for us, because the magnetic field of the Earth actually protects us from all this energy coming from the sun, the solar wind. If we did not have a magnetic field on the Earth, if the Earth wasn't a giant magnet, then the sun would be able to bombard us and impact all this stuff onto the Earth, and we probably wouldn't be able to be here. So we are very lucky that the Earth is magnetic, so that we are able to evolve and grow to be on the Earth. So now we have the 4 inner planets: Mercury on the left, Venus, Earth, and Mars. The 4 inner planets are rocky. They're solid and they're rocky. They're made of different rocks depending on what planet they are, but they're solid and rocky planets. Mercury looks a little bit like our moon, and it has very extreme temperatures because the side that points towards the sun is very, very hot, and the side that points away from the sun is very, very cold. And it's hard to look at Mercury from the Earth because it's so close to the sun. We can't look at the sun with the naked eye, or even with a telescope that doesn't have proper equipment. So never ever look at the sun, because it can burn your eyes. So looking at Mercury is difficult because it's so close to the sun. However, we have sent spacecraft to Mercury, and there's a British and European spacecraft called Bepi Colombo on its way to Mercury at the moment. So if you are interested in building satellites and building spacecraft and being part of the space industry, there are lots of jobs available in the UK building and doing the science. So that's Mercury. Then we have Venus. Venus is actually the hottest planet in the solar system, and that's because it's covered in a very, very thick cloud, and that traps all the heat from the sun in underneath the clouds of Venus. Now those clouds are so thick, and that the pressure on the surface of Venus is about 90 times the pressure on the surface of the Earth. So think about when we are allowed to go swimming, and if you've ever dived down to the bottom of the swimming pool and you can feel that pressure on your ears, imagine that, but 90 times stronger. It wouldn't be a very pleasant place for us to be. It would hurt quite a lot. And those clouds are made from an acid, and so if we breathed in the air on Venus, it would actually melt our lungs. So it is not a very pleasant place to be. On the surface of Venus, there are thousands of volcanoes. So Venus is a very, very active planet, but it would not be the sort of planet that human beings would want to go and visit and live on. And then we have the Earth and the Moon. And again, this picture is a little bit misleading because the Moon is not that close to the Earth. This picture is a bit more realistic. The Moon's quite big. It's about 1/3 of the size of the Earth. And if you think about it, human beings have only ever been to the far side of the Moon. We have sent spacecraft to much, 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 much further to the edges of the solar system, but human beings have only been to the far side of the Moon. And there have been astronauts on board the International Space Station on and off for the last 20 years, and I will show you some pictures of that in a little while. Now, this is what the Earth and the Moon would look like from Mars. So if you lived on Mars, if you were an astronaut living on Mars, that is what the Earth and the Moon would look like. And we are, well, in the future, we're hoping to send human beings to Mars. There were lots of plans by lots of different organizations to send humans to Mars in the next 10 or 20 years. But I think it would probably be a bit longer than that. I imagine that in your lifetime, there will be a human being on Mars. So if you're interested in being the first person on Mars, do study science and space and become an astronaut, and then you might end up being the first person on Mars. And then this little dot here, the little dot there, is what the Earth looks like from Saturn. So those are Saturn's rings in the edge there. So the Earth is starting to look really, really small. And then from the very edges of the solar system, that is what the Earth looks like. It looks like a little blue dot, or even like a star. And that's what the Earth looks like from the edge of the solar system. Then we have Mars. Mars is really interesting to us because it's quite close and we have studied it quite a lot, and we would like to send human beings there. Mars has got valleys and craters and some of the biggest volcanoes in the solar system. So Olympus Mons is the biggest volcano on Mars, and it's 3.5 times bigger than Mount Everest, which is our biggest mountain on the Earth. So Mars has got 3.5 times the size of Everest, Olympus Mons, on the surface of Mars. Now this picture, on the left, you've got a sunset on Earth, and on the right, you've got a sunset on Mars. And the reason I show this is because it's quite interesting that in the daytime on Mars, the sky is red, and at sunset, the sky goes blue. And that's because of the particles in the atmosphere making the sky look a different color. And that's interesting because if you think you have moved to, if you're an astronaut and you move to live on Mars, and then you get maybe poorly or a bit homesick, and then the sky's the wrong color as well, that could be quite difficult to live with. That could be quite a difficult thing. And Mars is red because the surface is made of rust. It's iron that's met with oxygen and turned into rust. And you might have seen rust in maybe playgrounds. If you see metal with red bits on them, that's rust, or reddy orange bits on them, that is rust. Moving on now to Jupiter. This is a real picture of Jupiter taken by a spacecraft called the New Horizons spacecraft while it was on its way to Pluto. Now, Jupiter is a gas planet, so what you're looking at here are lots and lots of different gases, different chemicals, different speeds, different temperatures. The shapes that you can see are because the gases are kind of moving past each other, flowing past each other. The colours also tell us how deep the gases go, so the darker ones let us see further into the planet Jupiter, and the lighter ones are higher up. And I just think this picture is beautiful. I think one of the things we have to remember about space is that it is ultimately really, really beautiful. And that is what Jupiter would look like if we could fly past it in our own spaceship. But it would take a very, very long time to get to Jupiter. And we couldn't land on it because it is a gas planet. Now, there is a spacecraft called the Juno satellite going around Jupiter at the moment. And this spacecraft has got astronauts on board. They're not humans, but I would like you to have a guess as to what those astronauts might be. So again, if you want to type it out, or if you want to just discuss it with the person next to you, you can have a go at guessing what astronauts are on board. So someone has written animals. They're not animals. They're not animals. There are robots, I suppose, because they're making the satellite work. They're not people. Mannequins, that's quite close. They're not dogs, they're not monkeys, they're not badgers, space badgers or otherwise. They're not insects. Okay, I'll tell you. I will tell you. They are, so the person that said mannequins, that was the closest. They are actually Lego people. So I'm sure you've all played with Lego before, and you've played with Lego people. So these three Lego people represent Jupiter, the god and goddess Jupiter and Juno, and the astronomer Galileo. And they are actually made by the real Lego company, but instead of being made out of plastic, they're made out of aluminium because of the harsh environment and the harsh temperatures in space. Okay, moving on to Saturn. Saturn's my favourite planet because I studied it for so long. And I use that spacecraft there, the Cassini spacecraft, to study Saturn. And I think Saturn, again, is another beautiful planet. and it's really, really famous for its rings. Now, when I was using the Cassini spacecraft to study Saturn, this is the Cassini spacecraft before it went there. And what you can see in the bottom left-hand corner is a person in white overalls. So you can see that the Cassini spacecraft is absolutely massive. It's about the size of a double-decker bus, so it's absolutely huge. And it was a really cool spacecraft. It took 7 years to get to Saturn, and then orbited, went around Saturn for almost 14 years. So that's a really, really long time. And it taught us a lot more about the planet than we ever knew before. So Saturn is about 10 times the size of the Earth, but it's another gas planet. And the gases it's made from are less dense than water, which means that if you could find a massive bubble bath to float Saturn in, it would float on top of the water because it's less dense than water. And Saturn is obviously very famous because of its rings. And the rings are really, really wide. They go out about 12 million kilometers. So from Saturn out about 12 million kilometers. So really, really wide, but they're very, very thin. They only go, they're only about 20 to 50 kilometers thick. So they're very, very thin. And the picture on the bottom right, there's a thin black line, and that is what the rings look like edge on. So they're very, very thin. Saturn is mostly made from hydrogen and helium and a few other gases as well. So that's Saturn there. There's lots and lots I could tell you about Saturn. I could do a whole talk just about the moons of Saturn, but maybe that will happen on another day because we will run out of time otherwise. Then we have Uranus. These are two pictures of the same planet over different times and taken by different telescopes. But what you might notice is that the rings of Uranus go from the north to the south pole. And what's happened, we believe, is that when Uranus was very young, it spun around the sun just like Saturn does, with the rings around its middle, and then something smashed into Uranus and actually knocked it on its side, and now it rolls around the sun like a ball, basically, with the rings at the north and the south pole. And that means Uranus gets 42 years of sunlight, followed by 42 years of darkness. So our days are 24 hours, and we get daytime and nighttime within that. But because Uranus rolls around the sun like that, it gets 42 years of sunlight, followed by 42 years of darkness, which is not very nice. I don't think I'd like that. I wouldn't mind daytime, but even then it would be quite stressful. Okay, moving on to Neptune. Again, two pictures of the same planet. We don't know a huge amount about Neptune because we haven't really studied it in much detail. We have taken a few pictures by different spacecraft, but we haven't looked at Neptune in much detail. But just like Jupiter, it has storms on it. So Jupiter has the Great Red Spot, and Neptune has little spots. It's got the big dark spot, it's got a small dark spot, and then this little one here is called Scooter because it's a storm that scoots around the planet very, very, very quickly. So again, they're not very imaginative names. Astronomers don't have very imaginative names. There's a question saying, is Uranus in daylight or darkness now? I'm not actually sure. You could check that out and let me know, because I'm sure you could find out using our friendly internet. And now I know that Pluto is a dwarf planet and not one of the main planets in the solar system, but I love showing pictures of Pluto because when I was your age, the only pictures of Pluto we had were just like fuzzy blobs. And then the New Horizons spacecraft flew past Pluto a few years ago, and these are the sorts of pictures it took, and they're incredible. I think that's an amazing picture of the planet, and you can see all the craters on the top show that that section of Pluto gets meteors impacted and smashing into the planet, but this bit here is smooth, and that means Pluto has got volcanoes on it. but the volcanoes are ice volcanoes, not lava volcanoes, and they're spewing out ice instead of lava. They're called cryovolcanoes. And I like showing this picture as well. Hopefully you know that that dog there is also called Pluto, and Pluto's face fits exactly into the smooth bit of the planet Pluto. I just think that's funny. Okay, so this is another cartoon. It's showing the Earth with lots and lots of dots around it. Now you might think those dots are stars, but they're not. They're actually, it's actually a representation of the satellites that human beings have put into space. And these are just some of them. These aren't all of them. So we are junking up space, but the satellites that we put up are useful. We use them for all kinds of things. They're weather systems, there's sat-nav, there's Sky TV, there's communication, there's military, there's all sorts of things. And we do rely on space technology a lot more than we realise. Now, we talked about the sizes of the planets, but we didn't talk about the distances between them. And because they're such big distances, it's quite hard to think about because the numbers are so big. So I'm going to scale the solar system down, and we're going to think about the distances between the planets. Now, I know at the moment it is quite hard to grab hold of toilet paper, but if you do have a toilet roll nearby, you're more than welcome to grab one and follow along. Now, what I've done is scaled the solar system down onto a toilet roll. So imagine the sun is at 0 sheets of toilet paper. If we unraveled the toilet roll, Mercury would be at 1 sheet of toilet paper. Venus would be at 1.8, so almost 2. Earth would be at 2.5, and Mars would be at 3.8, so almost 4. So the 4 inner planets, the rocky planets, Mercury, Venus, Earth, and Mars, would fit in about 4 sheets of toilet paper, which is not that many. If you wanted to then get to Jupiter, you'd need almost 4 times that. Yeah, almost 4 times that, so 13 sheets of toilet paper to get to Jupiter. But have a look at Pluto. To get all the way from the sun to Pluto, you'd need 100 sheets of toilet paper. So that would not fit in here. It maybe would fit in the park if you unraveled a whole roll of toilet roll. So it just shows that it's such a big place. The solar system is massive. If the Earth was at 2.5 sheets of toilet paper, Pluto would be at 100. And our solar system is actually 300 sheets of toilet paper large. So it's a really, really big place. And I'm going to just skip a few slides because we are running out of time, and I can talk about these another time. I mentioned before that human beings, so this is the picture of the Earth and the moon again, and that I mentioned before that human beings had been to the moon and had been to the far side of the moon, but that was as far as we've been, although we have sent spacecraft to Pluto and beyond. But we have had human beings on the International Space Station for the past 20 years. Not the same people, but we have like maybe 6 astronauts on board. They stay for 6 months, and then they'll come back down at the same time as 6 others go back up. And that means that there have been human beings in space for the last 20 years. Now, the International Space Station flies about 400 kilometers from the surface of the Earth. And if the Earth was the size of an apple, the International Space Station would be flying at the apple skin level. So not very far at all, but still technically in space. And if you are interested in becoming an astronaut, generally what you have to do is study science or engineering or any of those other jobs, medicine, etc., and do your job for about 3 years. So you're an expert in your job, and then you can apply to be an astronaut. And if you do get onto the astronaut training program, you get to do all kinds of fun things. It is a lot of hard work as well. So there's a lot of classroom work. You have to do lots of maths. You have to learn Russian. You have to do teamwork. But you can also train to be an astronaut by doing scuba diving. And what scuba diving is swimming at the bottom of a really, really big swimming pool with an air supply so that you can stay down there for about 6 hours at a time. And this picture is the biggest swimming pool in the world. It is owned by NASA, the American Space Agency. And at the bottom of that swimming pool, you can see a pretend version, a mock-up of the International Space Station. And astronauts train by scuba diving, and they practice their mission in this giant swimming pool. They train for about 2 years, and then they are able to fly up to the International Space Station. They are the only way into space at the moment for human beings is to go on a Russian spacecraft called the Soyuz, and the astronauts sit at the very top of that spacecraft. There's about 3 astronauts at a time that go up into space at the top of that spacecraft. And then in about, I think it takes about 8 hours to get to the International Space Station. And hopefully some of you have been tracking the International Space Station and have been able to see it in the sky over our heads. I think last week it was visible, and there are a few other dates coming up when it is visible. And you are able to see the space station. It looks like a very bright dot moving quite quickly through the sky at night. So do keep an eye out for that. Now, astronauts, when they're in space, they have to do lots of things. They have a very busy schedule, but they do get to have a lot of fun as well and float around in a microgravity environment. They have to put their spacesuits on and go outside and fix different parts of the space station. So those are called spacewalks or extravehicular activity. They also have to do about 4 hours of exercise every day to keep fit and healthy. So there's Tim Peake on an exercise bike, but he's strapped in so he doesn't float away. And they have to do science experiments in space. So this science experiment is growing flowers in space. But if you imagine, if you were trying to do gardening in space, the soil would float away and the seeds would float away. So this flower has been grown in a little sack full of soil and seeds, and it's kind of like a little pillowcase. And then they have to eat. So this is what space food looks like. There's lots of different types of space food there. There's tea in a pouch, and there's some M&Ms, and there's a tin of something, there's a chocolate bar. And space food has got a lot better over the years. Initially, it used to be like really bad camping food where you just add hot water and it wouldn't taste very nice. But now they can make pizzas, and sometimes they can bake cookies, and they do have a lot more choice as well. And then they have to do normal things. So here Tim Peake is cutting his hair with some electric clippers, but you can see the clippers are attached to a tube, and that tube sucks away the little bits of hair, and that prevents those bits of hair from floating about the space station and interacting and affecting the equipment that's there. Here we have Samantha Cristoforetti. She's an Italian astronaut. And does anybody know what she's holding? Anyone want to have a guess as to what contraption she might be holding? What do you reckon? It does look like a Hoover. You're absolutely right. It does look like a vacuum cleaner or a Hoover. It is a toilet. It is a space toilet. So the yellow funnel is what you go into. So you aim into the yellow funnel bit, whether you're doing a number 1 or a number 2, a liquid or a solid, a wee or a poo, goes into that tube. Then the wee gets recycled, and all the wee is taken out, and what's left is water, and the astronauts drink the water. And the poo gets frozen and basically gets chucked out the window, so it burns up in the atmosphere. So that's the way they get rid of the poo. So sometimes you might see a shooting star in space, or what looks like a streak of light in the sky. And sometimes that might be poo from astronauts burning up in the atmosphere. So pretty disgusting, but there we go. And then they also get to look out the window. Yes, they do drink toilet water. And actually, even on the Earth, we drink recycled water. So we kind of drink toilet water as well. But, you know, you have to use what you've got. So they astronauts also get to look out of the window, which is lovely. Very exciting, because the views must be incredible. And if you tilt your head to the right hand side, what you might see in this picture is we are looking at the UK and England and Scotland and Ireland and Wales at night time. and the lights from the big cities are much brighter than the countryside and the rural areas. So you can see England and the UK at night time. Another question, how do they wash their hands? They do have water on board the space station. They don't have a free-flowing tap, because again, the water would flow off into the space station. But what they do is wet flannels, and they use a flannel to wipe their hands, a bit like baby wipes. So they do have water, and they are very clean. It has to be a very clean and hygienic place, but pretty much everything they use is recycled. After about 6 months, they come back down to Earth in a little pod, in a little capsule. Coming back down to Earth takes about 3.5 hours from leaving the space station to landing in the desert using a parachute. And then they have to be checked out by doctors, because being in space for that long can affect your muscles and your bones, and can make you feel a bit seasick and stuff, well, space sick and stuff like that. But as you can see, it's difficult, but it's also super fun. And the main thing about space is that space is for everyone. I know we're in this lockdown situation at the moment, but you can still go outside and look at the stars. And at the moment, I feel like the sky is really clear, and you're able to see Venus, and you're able to see the International Space Station. So do go outside and have a look at the stars, and have a think about the astronauts up there in space. Okay, I'm going to stop sharing the slides. And what we're going to do now, if you have any more questions, we've got just under 10 minutes for questions. So you are able to ask me questions now if you want to. You don't have to if you don't want to, but if you do, then you can type your questions to me. If you've already asked me one and I haven't answered it, can you please type it again, because I probably missed it. So one of the questions, why is gravity not in space? Well, gravity is in space, and actually gravity is the most important force in space because it holds everything together. Gravity is the reason that there are rings around Saturn. It's the reason that all the planets go around the sun. It's the reason that galaxies form, etc., etc. When you're an astronaut, what you're doing is essentially you're falling in space, and you're falling around the Earth. When the International Space Station orbits the Earth, you're essentially falling. A bit like if you've ever been on a roller coaster or even on a bus or something, and it goes over a hill and your tummy flips a little bit and you feel a little bit like you're falling. Astronauts are basically doing that all the time, and that's why they're in a microgravity environment. If you go to a different planet, there's less gravity or more gravity depending on how big the planet is. So for example, on the moon, the gravity is about 1/6 of the gravity on Earth, and you can jump really high and throw a ball really far because the gravity isn't pulling things down. If they throw up on the International Space Station, they try and do it in a bag so it doesn't float around. Sometimes there are messy situations that happen in space, but generally astronauts are very fit and very well. And if you have health conditions that may cause you to throw up a lot, then you would not be picked to be an astronaut. How will the universe end? Well, there's lots of different ideas as to how the universe will end. We believe that the universe was created at the beginning with the Big Bang, so a sudden explosion which caused the whole universe to be created. And one of the ideas about how the universe will end is that there'll be so much stuff in the universe that it'll all come together under gravity, and instead of a big bang, there will be a big crunch where everything will become just a small, one single point. So from Big Bang, grow, shrink to a big crunch. Whether that big crunch then causes another Big Bang or not, we don't know. And there are lots of other different ideas about how the universe will end, but we don't really know. So it's quite interesting. On the fruit-sized solar system, how big would Pluto be? I think it would probably be similar to Mercury. I'm not 100% sure how big Pluto is. It's probably smaller, a bit smaller than Mercury. but it would be very, very tiny. So sort of peppercorn or smaller. What food can you not eat in space? There's a few. So fresh fruit and vegetables are not easily accessible. They get a delivery about once every 3 months. So you can see it's very similar to being in lockdown, but they do have freeze-dried fruit and tinned vegetables and things. You can't eat bread in space because when you break bread, it crumbles, and those crumbs could float off into the electrical equipment, and that could be quite bad for the space station. So generally in space, if astronauts want a sandwich, they use tortilla wraps instead of bread, so that you're not allowed to eat bread in space. Can you light a candle in the space station? You can. You have to do it very carefully and for a particular reason. So you can't just light them for fun, unfortunately. But it's really interesting because imagine a candle on the Earth and the flame kind of goes upwards. And that's because of, it's to do with gravity and air and what the conditions that we have on the Earth. So the flame is kind of thick at the bottom and then it goes upwards. But a candle in space, because there's no gravity or microgravity, the actual flame is like a sphere. It's like a little sphere of fire, like a little fireball. There are pictures on the internet, so do have a look at that, which would be very cool. How many stars are there? Very good question. There are more grains of sand on the whole Earth. No, wrong way around. There are more stars than there are grains of sand on the whole of the Earth. So imagine when you go to the beach and you fill up a bucket with sand. Each individual grain, there's billions and billions of grains of sand on the Earth. There are more stars in the sky than there are grains of sand on the Earth. So that is crazy. Do I think there has ever been life anywhere else in the solar system? It's possible that maybe Mars once had water on it and therefore maybe had life like us on it, but we haven't found any concrete evidence of that yet. There's also moons of Jupiter and Saturn, particularly Enceladus at Saturn, which has an ice crust and a water ocean underneath. And Cassini, the spacecraft, has measured the water, and that water is salty water, like our oceans, and it also has things like carbon, nitrogen, ammonia, lots and lots of what we call building blocks for life. So if there is life in our solar system, other than on the Earth, I would put my money on it being on Enceladus, which is a moon of Saturn. But I don't think it would be like intelligent life or life like us. I think it would be like microbial life, so tiny little bugs swimming about in this ocean on this moon of Saturn. Okay. Can you have peas in space? Yes, you can. And can you be gluten-free? Yes, you can. We can cater for lots of different dietary requirements. Peas would be easier to eat when mixed with something else, or maybe mushy peas, because then again they won't fly away. Allergies wouldn't stop you being an astronaut, because you can, nowadays there's lots of different things that astronauts can eat and lots of different things that we can eat, so not too bad. How many people have gone to the moon? There's only ever been 12 men who've landed on the moon, and they were all American, and that was in the 1960s and 1970s. So it would be really great if there were other people to go to the moon that weren't men and weren't American. Maybe one of you guys could be the first British person on the moon, or you could be the first person to go to Mars. It would be very cool. The moon is made of rock, very similar to the surface of the Earth. And we believe that is the case because we think when the Earth was very young, something smashed into the Earth and a chunk of the Earth broke off, and that is what the moon is made from. So the moon is very similar to the surface of the Earth. Okay, just having a look at why does Saturn have ice rings? Well, Saturn has got lots of different rings made of lots of different lots of different stuff. The inner rings are dust and rock. None of the rings are solid. They're all lots and lots and lots and lots of small particles and blobs of things in gravity around Saturn. So you couldn't like stand on the rings. It would be a bit like being in a snowstorm or a hailstorm. And some of the rings are made from rocks and dust, and some of the outer rings are made from ice. And that moon that I mentioned, Enceladus, is actually spewing ice and water out into the Saturn system at the same time as going around Saturn. And that moon actually creates the ice ring of Saturn. So there we go. Right. We are pretty much at the end of our session today. What I'm going to do, I am writing my email address in the chat box. And also, if you reply to the Eventbrite emails that you've got, they also come directly to me. Feel free to email me if you have questions, or if you have any suggestions of what topic you would like me to do next, because I will do another primary school session in about 2 weeks' time, and I'm happy to do this topic again, or I'm happy to do another topic if there's something that's interesting for you. And do keep in touch if there's anything you change, or if there's anything you want to add, or if you want to send me pictures or anything like that. Do keep in touch. Like I said, you can email me, and I put my email in the chat, or reply to the Eventbrite email, and I will get those emails too. Happy birthday to Mark again. Have a lovely 40th birthday. Hope you have a space-themed birthday party with your family. And thank you everybody for joining me today. I hope you enjoyed it, and I hope to see you again soon. Stay safe and stay well. Take care. Bye.